So we've done all the setup for how to find expected values and how to find out whether you're doing a test for homogeneity or independence. So now let's actually run the test. Notice that as in similar tests, we're not going to be doing this test by hand. We're going to use calculator and or computer outputs to do this because that is the best way, honestly. So step one, you're going to have to choose whether or not you're doing a test for independence, which would be these types, or homogeneity, which would be this. The rest of the test is exactly identical. It doesn't matter for the rest of the test which one you're doing, except for obviously stating your conclusion. So you have to choose which is the correct test and hypotheses for what you're trying to do. Then you'll select your level of significance. Then you'll calculate all your expected frequencies. Verify your requirements. Now, again, like in chapter 11, you for that one type, oh, excuse me, not chapter 11, sorry, chapter 12.1. The requirements are actually down here for running the test, which is you want all expected counts to be greater than or equal to 1 and no more than 20% of the expected counts are less than 5. That's that whole, we start lumping things together if they're really, really small. That probably won't happen to you in this course, so you can kind of ignore it for our purposes because we'll always give you some pretty good tables. But if you ever have to run a test like this on your own, you would lump groups together. Then you'll find your test statistic, but notice it says use the computer output, right? We are not going to do this by hand. And since we're using our calculator to do this, we're not going to need to do this formula by hand, which is a good thing because it can get tricky. Now, if you're doing the classical approach from there on, you'll find your critical value in your chi-square table, and then you'll use the r-1, c-1 degrees of freedom and such. These are always, always right-tailed tests, no matter what. All chi-square tests for independence or homogeneity, right-tailed, no matter what, just like the goodness of fit. So you don't have to worry about doing left-tailed, right-tailed, all that stuff. They're all right-tailed. If you're doing a p-value approach, same thing. You'll do a right-tailed test, but with the p-value labeled and your chi-0 squared. Then you'll just reject as usual and state the conclusion. Of course, you only reject if you can reject, but we'll get there. All right, so now we're going to run this test with the calculator just to show you how. And it's going to get a little bit complicated. So I want to use the TI-84 to come up with this output here. So the first thing I'm going to have to do is I'm actually going to go back to the original data set that we had for, oops, sorry, I went too far. There we have it. For happiness and income, right here. This data set. This is going to be our observed data set right here. All right, now what do I say? How am I going to put this into a calculator? And you can't put it into a calculator into a place that you've used before. You're going to have to put it in a place called the matrix menu. So over here above this little x-1 button, says matrix. So you want to go in there into the matrix menu. And you want to pick number 1, say letter A. Oop, I'm sorry, I already messed it up. See? All right, matrix menu. You don't want to just choose it because you're on the names menu. You actually need to edit. So you need to go over here to the edit menu and you want to edit number 1. And now you want to tell it how many rows and how many columns. So it's a 3 by 3 matrix. So that was the number of rows times the number of columns. Then you want to enter in all your values. So you have 172, enter. 383, enter. 132, enter. And if you keep pressing enter, it'll work its way down the matrix. So you're filling in these values in the table. 293, 26, 233, 164. I'm just pressing enter, enter, enter as I go. All right, one more time to get there. I went to matrix, which is above your x-1 button. I go over to the left to the edit menu. And I pick number 1. You can actually pick any number you want, but I just pick number 1. Then I tell it I wanted a 3 by 3 matrix, so it gives me 3 rows, 3 columns. And then I enter all my values. Now I'm going to do it again, but I want to do it for the matrix B, number 2. And here I want to get my expected values, which is also a 3 enter matrix, 3 by 3. Now, if you remember, to find those expected values, we sat there and did it by hand. You multiplied 687, which was your row total, times 315, which is your column total, and divided by 1993. And we rounded that to 108.58. But here's the kicker. You don't have to round it. You can actually just type 687 times 315 divided by 1993. Enter. And it finds it, see? But it actually stores more decimal places than you had. Then you can do it again. Now I could have done this, oops, clear. I could have done this when I did the original typing, but I thought that would just get too confusing for your first time through. So 687 times 1089 divided by 1993. Enter. 687 times, oh my goodness, times 589 divided by 1993. And you can see the numbers are popping up just like we thought they would. And it's matching all the numbers we already found when we did this in the last video. But if you didn't do it in the last video, now you can do it now. It's honestly more efficient to do it in here. It's a pretty small font, but it's better for you because then it's already stored in the calculator if you're going to do it by hand. If you're not going to do it by hand, then you don't really care. 589 divided by 1993. And by do it by hand, of course, we don't do the formulas by hand, but we could maybe have to run the rest of the test if we weren't given a computer output with the p-value, for example. All right, so notice all my numbers in there match. Maybe you can't see them, but they all match the values that we had earlier, but they have lots of decimal places. So if I move around and down through this table, you can see it stored all those decimal places. All right, so let me go back to the matrix menu really quick. Number 1, of course, had my observed, what really happened. Number 2 had my expected values. Okay, so now I'm going to use those to run the test. And the instructions for it are right here. See, there's all the matrix stuff. And then I'm telling you here how to run the test. So if you go to Stat, Tests, go up because it's one of the last ones. It's the chi-square test, letter C, right there. So if you grab that, then you tell it your observed is in matrix A. Now suppose matrix A wasn't in there. Well, that's when you use the name feature. So you go to second matrix and you hit number 1, since that's where my observed matrix is, and press enter. And then a matrix B was where my matrix was, so I don't have to do that again. But if you had to, let's say you weren't sure or whatever, you'd pick number 2, and there you go. And it puts those names in that observed and expected value area. Then you go down to calculate and press enter. And there you have it. And it's the same output that I give you right here. See that? That's how you create it from the calculator. Now TID3s do not have this. They can't run a chi-square test for independence like this. Only TID4s can run this test. So that's something to think about. Now if you don't have a TID3, you can use Statcrunch. You sign in with your regular username and password that you use to get into my math lab. And then you go in here. And the first thing you're going to have to do is recreate your tables for happiness and income and all that jazz. So I'm going to have to type up my tables that I had in my notes. Back here, the original table. I'm going to have to type that up in some of the columns right here, this part. So I'm going to go type that up and I'll be right back. All right, there you have it, and it's the same table. Here, let me show you. It's the same table I had before. It's just kind of all written up. So I've got my below average, my above average. And you can make these wider so you can see them. And then you have 172, 117, and so on. Everything's labeled and everything. Okay, so then you actually don't need to find the expected values in here because Statcrunch will find it for you. So you go to Stat, you go to Tables, you choose Contingency Table, and you have a summary. So click with Summary. Then you tell it where the columns of data are. And the columns of data are in Not Too Happy. Now hold down, see what it's saying? Hold down Control and click and Control and click. You're holding down the Control button the whole time. So I click, click, click on 3 of them with the Control button held down. Then I go to my row variables and I click Income because that was my rows right there. Notice these 3 are still having like that kind of darker gray on them. All right, I don't have those options. And I actually can tell it, tell me the expected count. And then I don't really need any of this rest of the stuff. So I'm just going to click on expected count. And then I'm running a chi-square test for independence. That's what we're doing right here. Okay, so I'm going to click that, and none of the rest of this stuff do I want to do. Ignore the confidence interval stuff. That's more involved than we're doing. And don't bother with that marginal homogeneity. It's tempting, but don't do it. We're going to stick with the chi-square test for us. And click compute. And hey, look at those numbers right there. See that? 108.58, 375.39. Look familiar? Well, they should, because they're the same numbers we came up with right here. See? 375.39 and so on. So Statcrunch is really nice because it actually finds all those expected values for us. And then down here, it gives us the chi-square value, the test statistic, the degrees of freedom right there, which we already found was 4, and our p-value is really small. It's less than 0.0001. All right, so that's how to run these tests with either the calculator or with Statcrunch, whichever you happen to have on hand. But now we actually have to finish out the steps, so let me fill those out. All right, in step 1, we have that income and happiness are independent, and then income and happiness are dependent as our two hypotheses. Remember that another way to say dependent would be not independent. And then up here they tell us that alpha is 0.01 as our level of significance, so that's alpha right there. Then the chi-0 squared, remember, we just want to grab it from the calculator or computer output. We're not going to find it by hand. We're just going to use the calculator. And the calculator tells us that it's 106, oops, there it is, 106.955. So that's our chi-0 squared. Now we're going to draw the picture. Now remember, this is always a right-tailed test no matter what. And it's a chi-square distribution with degrees of freedom equal to 4, which we found already. All right, so there we have it, and I'll be honest, I fudged it. It's not even this close. It's way far over to the right because it's well past what the screen is showing. But just to kind of give us a little graphic visual here, 106.96 is over here on the far, far right, and the p-value is that area in that tail, which the calculator tells us is 3.24 e negative 22. So realize that's 0.000000, like 21 zeros and then a 3. Minitab wouldn't even bother with that. Minitab would just basically call it 0, right? So, and if you'd like, you can do that as well. There it is, and say that it's approximately 0, or you can write out the scientific notation for it, which is 3.24 e negative 22. Now that is an extremely low, very, very low p-value. That's one of the lowest we've ever seen, which means we are going to reject the null hypothesis. Because that p-value that we have, which is 3.24 e negative 22, is less than our alpha, which is 0.01. And that means, despite what the Beatles would claim with Money Can't Buy Me Love, they're not exactly correct. There is sufficient evidence to support the claim that income and happiness are not independent of each other. And that is, income and happiness are dependent upon each other. In other words, money perhaps can buy you love. All right, we're done with that test here, and I'll see you back here to do one more test before we're done with chapter 12.